Welcome to another lecture on microelectronics. Today we'll be solving this circuit to find. So in today's lecture we'll see how we can solve a network like this in order to solve for the gain. So if you recall, and gain is given as V out over V in, and this is equal to G, where V out is the output voltage and V in is the input voltage. So from this network we can see that the output voltage is across this resistance RL. The input voltage here is connected to this point. So this circuit can be drawn in a simplified way. We know that R pi connects to V in at one point, and the other point of both V in and R pi are grounded. So in effect, R pi comes in parallel with V in with what polarity? So R pi is, V pi is positive, where this point is connecting with the positive of the input voltage. So it has a polarity like this, and this is V pi. From here we see that V pi is equal to V in. Then we have this voltage controlled current source VCCS, which depends on the voltage V pi, and V pi we already know is equal to V in. So at this node if I write KCL, then I know that the sum of these two currents, I1 and this current, should be equal to 0. I can write that I1 plus this current would be V0 over RL is equal to 0. And I1 in turn is given by Gm times V pi plus V0 over RL is equal to 0. And V pi we know is equal to V in. So substituting here, I get Gm times V in is equal to minus V out over RL. And from this equation, V out over V in can be written as minus Gm times RL. So this is the gain of this circuit. So that's it for today. See you in another lecture where we'll be solving some other microelectronic circuits. Thank you.